So we want to look at the thermographic analysis techniques, though we have described them before in the course of our explaining how to analyze those thermograms that we saw earlier. So, but let's just bring it home for us to appreciate the techniques that we have used in those analyses. Okay, so like we said in the beginning, we have both the quantitative and the qualitative analysis. So in a qualitative analysis, what you do is that you just do a general scan, okay, and look for anomalies. Are we getting it? Something that is different from what is usual. That is the qualitative analysis. Okay? So like looking at the normal temperature gradient, looking at the the thermogram to see if you have hot spots and what have you. All of those they fall into qualitative analysis, and that is what is we are seeing here. There are issues here, but the magnitude of the issue we will not state it. Okay, you look at this transformer, you see, okay, look at a thermogram. As we discussed earlier, the thermogram is normal. This cooling fan is working, this one is working. Whether such an observation is normal to the operation of the transformer or not. All of those, they are qualitative analysis. Whether we have hot spots around the connection points on the bushings, okay? So all of those, they are qualitative analysis. Then we also do thermal pattern recognition, okay? Which is something like this. So what is different from this, we know it is abnormal. Like we said earlier that every equipment emitting infrared energy, okay, all operating equipment emitting infrared energy, they have their normal operating thermogram, whether mechanical or electrical, even process, because they have the normal amount of heat by virtue of their operations that they give out. Okay, so they have their normal thermogram. So once you recognize that, anything outside that becomes an abnormal thermogram. Okay, so that pattern you recognize it. Then hotspot identification, as we said before, you can scan a wide area, okay, a full substation, just looking for hotspots, okay, hotspot like this. So once you see something like this in the thermogram, okay, or in your survey, of course, you now zero in or focus on that point to try to determine whether it's a fault condition, and if it's a fault condition, what could be responsible. Okay, so that's for the hotspots. Then the quantitative analysis. Now you've seen the point of interest in your thermogram. Let's assume like this now. You want to determine if this hotspot is really a hotspot or something that can deteriorate further and subsequently cause damage, okay, to your system. So it's now left for you to try to determine the spot temperature, okay, by moving this cursor to the particular point that will give you the spot temperature. Are you getting it? So with that spot temperature, you now compare it with your ABN temperature. If assuming your ABN temperature is 37 or 40, okay, so which means your delta T will be 20.7, which is normal because the rule of thumb is that if your delta T is going beyond, say, 40 degrees Celsius, okay, that should give you a cause for concern on all operating equipment. If that equipment is not meant to operate at such a high temperature. So here, if it's here now, say ABS is 40, okay, which is 27, that may not be a cause for concern. Say 20 degrees Celsius, but as it's increasing, you see it. Okay, once it increases beyond 40, you now say, okay, this problem has deteriorated to the stage where we need to do something. Then you could also observe hotspot here. You now make a quantitative measurement of the value of the heat, the temperature at that spot, okay, and compare it with the ambience and look for your delta T. Okay, on electric motors, for example, on the nameplate, you see the delta T, okay, on the nameplate. So you take your ambient temperature, take the temperature of the hottest spot on the motor, get your delta T. If it is not more than what is recommended on the nameplate, fine, the motor can continue running. But if it's more than, that means something terrible is happening. So this is what I was saying. You take the spot temperature, okay? When you take the spot temperature by moving your pointer in your thermogram, okay, to the spot, and then you take the ambience. This could give you the ambience because this is a frame that is not connected to the electric motor, so it has direct connection with the ambient. So the temperature here will give you the ambient temperature. So you subtract it from the spot temperature on the hottest spot on the electric motor. So the delta T reading, you will now compare it with what you have on the name plate. So that is how you analyze the thermogram that you take with your infrared camera. So you see that all of this, we have gone through them in the course of the analysis of the various thermogram that we looked at.